Good morning, children. This is my first video, and I thought that बहुत सारे बच्चों को, many students, they find difficulties in finding the direction of induced current. How to find direction of induced current? I am talking about chapter 6, electromagnetic induction of class 12. And to find the direction of induced current, we use Lenz rule. Lenz rule, if I specify, theoretically different. How we apply and get direction of induced current in seconds. So I'm going to give you some ideas about it. जरूर से आप लोगों को अच्छा लगेगा. Let's understand Lenz rule first. Lenz rule is same like inertia which you have learned in class 11. It's kind of that. Everything opposes the change. If an object at rest wanted to be at rest, if an object in motion wanted to be in motion. Lenz thought a similar way. So induced current, whenever we get in any circuit, any coil, it opposes the change. So what is it basically? I am going to explain in simple words. But before that, before I apply Lenz rule, some technique which I feel easy to grasp and understand by you people, let me discuss that part. Now, when I talk about a coil, in a coil current can flow either clockwise or anti-clockwise. Suppose this is a coil. In this, current is flowing which way? Clockwise. Current is flowing clockwise. So here if I ask you magnetic field at the center, direction of magnetic field at the center, you will tell me, sir, we will apply right hand thumb rule. Right hand thumb rule everyone knows at this stage because you have learned in class 10. कोई दिक्कत नहीं, we will not apply any of these rules. A simple rule I am going to give. My rule which I have made it in simple way, clock. And another way of current which can flow in this loop anti-clockwise. There are two ways where the current can flow, either clockwise or anti-clockwise. Listen carefully. Many places in class 12, you can apply this rule and your answer will be correct. What is that? Suppose you have a friend circle in which there are 5 friends, but one of them always talks anti about you, always says something negative about you. So what do you want to do? You want to kick him out of the group. Anti, anyone who talks anti, you want to throw him out. Anti, out, remember. So whenever current flows anti-clockwise, direction of magnetic field at the center is outward. And outward we represent with dot. So remember, current anti-clockwise, magnetic field perpendicular to the plane and outwards. That is important. Current flows anti-clockwise, magnetic field will be perpendicular to the plane and outwards. So for this plane, I am talking about this board, it is in vertical plane, right? Your notebook is horizontal plane. So for this plane, this is called outward. So now if you see in this case, how is the current flowing here? If you see in this loop, current is flowing clockwise. So clock means perpendicular to the plane and inward. So the magnetic field will be this way. So what is the most important thing which I said right now? Anti-clockwise outward, clockwise inward. Anti-out, clock in, remember. Now, let us see the direction of induced current. Whenever a coil enters in a magnetic field or leaving a magnetic field. So for that, let us understand a simple question first. I will begin with a simple question here. So you can see here I have drawn magnetic field with into sign. Into means magnetic field perpendicular and inwards. How is the magnetic field? Perpendicular to the plane and inwards. And if you see a rectangular coil ABCD is going out, whenever there is a change in magnetic flux, Faraday's law of EMI, whenever there is a change of magnetic flux, there is an induced EMF or induced current if the circuit is closed. That we knew before. So here you can see when you are moving it out, the magnetic field lines linked with this coil decreasing because area of the coil inside the magnetic field decreases. Now direction of induced current. I want to know the direction of induced current, and according to Lenz, what he said, it opposes the change that causes it. Opposes the change means if something is increasing, it says no, don't increase. If something is decreasing, again it says no, don't decrease. कोई बढ़ रहा है उसको बढ़ने नहीं देना है, किसी के पास कुछ कम हो रहा है उसको कम नहीं होने देना है. It always opposes the change. So again I repeat, if someone is coming close to you, it says no, don't come close to me. If someone is going away from you, it says no, don't go away from me. So it always opposes the change. Keep that in your brain. Let us begin now here. In this coil, in this case which I'm discussing here, magnetic field linked with the coil. What do you think so? Is increasing or decreasing? The moment you are moving the coil out of the magnetic field lines, the magnetic field linked with the coil decreases. So it's decreasing. Which way? Perpendicular and inwards. Because into means perpendicular and inwards. So it's decreasing. In which way? Perpendicular and inwards. So it's decreasing. So induced current what induced current says? I will oppose the change. Opposes the change. Opposes the change is very important. Always induced current opposes the change. What does oppose means? What is happening to the magnetic field lines? Decreasing. Magnetic field lines are decreasing. So what it says? Don't decrease. I will support you. Support means I will give you magnetic field lines inward. I will give more magnetic field lines inwards. Now if you want to give magnetic field lines in, couple of minutes before I told you, anti out, clock in. So whenever I say it wants to give magnetic field lines inward, inward means clock and outward means anti. Anti out, clock in, remember. So the current will flow here clockwise. This is induced current. So direction of induced current is which way here, children? Direction of induced current is clockwise. Why? Because it wanted to oppose the change. And the change was what? Decreasing. So it says no, don't decrease. I will support you. Is that clear, a little bit of it? Again, let us have one more example. Before that, always remember anti-clockwise outwards, clockwise inward. Anti-out, clock in. And induced current nature oppose. If you know these two things, you can do any numerical based on it. Let us see one more case. Suppose What dot represents? Magnetic field perpendicular to the plane and outward. Magnetic field is perpendicular to the plane and outward. Think something is coming out of it. So magnetic field perpendicular and outward. That is very important. First we should know how is the magnetic field. Now let us think. I have drawn a circular loop which is moving in. As you can see, it is entering with the velocity v. A circular coil is entering inside the magnetic field which is perpendicular and outward. Can you predict the direction of induced current? Is it clockwise? Is it anti-clockwise? Think clock or anti-clock. For thinking again, first see magnetic field, what is happening? Magnetic field is increasing or decreasing? So if I see the magnetic field increasing, right? What is happening? It is increasing. Which direction? As the coil enters, more lines will associate with it. More lines will pass through it. So magnetic field lines are increasing outwards. Increasing outwards. This is first thing which we begin with. So magnetic field lines are increasing outwards. That step is clear. Next, induced current. What induced current does? Induced current opposes the change. Induced current always opposes the change. And what is happening? It's increasing. So induced current say, no, don't increase. I will decrease you. What it does? I will decrease you now. If something is increasing, it wants to decrease. If something is increasing, it wants to decrease. Opposes the change. So I want to decrease you. How will induced current decrease is? By giving magnetic field lines which way? Out or in? This is outward right now. So it's increasing out. It's increasing which way? Outward. So induced current will decrease it by giving magnetic field lines inward. Because magnetic field lines are increasing outward, so induced current will give its magnetic field which way? Inward. So how to give inward? Clock in, anti out. So the current will flow here clockwise. How the current will flow? Clockwise. So induced current will flow clockwise. That is what we apply to get the direction of induced current. So these are the questions which are direct. Now sometimes magnetic field is not given. A numerical comes in board where the magnetic field is also not given. And then you have to predict what happens. So one of the applications question which is very frequently asked in board, I am going to discuss with you now. Please, if you like and you understand, do share with your friends, and in comment box let me know what way you want me to improve, because it's the first video I'm making it for you, and I would like to continue and giving my more contribution to you people. So please share it and like it, and tell me if you want me to speak in Hindi in between. I am ready to do so. So Hindi, English, dono in between I can do. So just give your opinion, honest opinion in box, okay? Suggestions. So I want that honest opinion from you in comment box. This is a case where I am going to decrease. I am going to see what happens the direction of induced current in a circular loop which is kept above the wire AB, or let's say wire PQ. Why I am telling PQ? Because B we give symbol for magnetic field. So I am not giving AB. It's up to us. We can give MN, LP, any symbol, any letter. So this is the direction of current which is decreasing this current is decreasing, suppose, in this wire. So will there be any induced current? Now there are three possibilities. This current either at steady rate, neither increases nor decreases. So if the current is steady, there is no induced current because there is no change in magnetic field. If current increases or decreases, the magnetic field will change with this. The problem is right hand thumb rule. I am a lefty. I play with left and right with right. Playing all with left. I've seen many lefties, those who use their left hand, they right hand thumb rule they apply with left hand because automatically your left hand responses. For that purpose I have made this rule anti out, clock in. So how to apply this rule here? You must be wondering, how can I apply, sir, here clock and anti-clockwise? I can't see clock and anti-clockwise here. So that is what I am saying it. I'll give you some simple techniques, remember it, and you will do numericals without mistake. What is the technique? In this wire, look the direction of current. Turn the wire in your mind. You have to think, imaginary. Turn the wire in the direction of current towards the loop. Turn the wire in the direction of current towards the loop. Which way it is turning? You can see it is turning anti-clockwise. In which sense it is turning? Anti-clockwise. So direction of current, if I apply here and see how is it flowing? Anti-clockwise. And anti means out. Anti means out. So the magnetic field lines here will be outward. First thing which we understand, that magnetic field lines here outward. So these magnetic field lines are not given. These magnetic field lines are not given. So this is a question where they want to judge you. Can you apply can you apply right hand thumb rule? So that is the first thing which we applied in simple way. I turn the wire towards the loop and I can see its current is flowing anti-clockwise. If the loop was below, then clockwise. So here the magnetic field will be inward. So in this loop, circular loop, magnetic field lines are outward. That much is clear. Now what is happening to the current? Induced current direction I want to know. This is conventional current which is flowing through the battery or something. There may be a source connected here which is just we turn off, so current decreases. So it's a conventional current. So the magnetic field lines, when this current, when I decreases, you know the magnetic field is directly proportional to current. Magnetic field is directly proportional to current. Remember this, whether it is a solenoid, whether it is a circular loop, whether it is a straight wire, magnetic field and current are direct proportional. If current increases, magnetic field increases. If current decreases, magnetic field also decreases. So what is happening here when current decreases? The magnetic field decreases, right? If current decreases, magnetic field also decreases. Now comes the oppose. Induced current says, I will oppose the change. What induced current says? Induced current flows in such a manner, it always opposes. What it does? It always opposes the change. And what change you observe? Magnetic field is decreasing outwards, right? It's outwards we have decided before by using clock and anti-clock rule. So how is the magnetic field decreasing? Outward. So it says, no, don't decrease. I will give you more lines outward. I will support you now. Whenever it decreases, it opposes the change. So it says, don't decrease. I will support you. Who will support? Neither you nor me. Induced current. कौन support कर रहा है इसको? Induced current. It says I will flow in such a manner that I will give you more magnetic field lines outward because you are decreasing. So I can't see you decreasing. I will give you more lines outward. So when it gives more line outward means current will be correct. Outward means current will be anti-clockwise. Out means anti. So induced current here, which is induced current. How is the induced current flowing? Anti-clockwise, because it says I will oppose the change, and the change was decreasing of magnetic field lines outward. So it says no, I will give you more lines outward. And whenever we decided out, anti-clockwise. Whenever we decided in, magnetic field lines inward, clockwise. So I can either way apply this rule. So anti-out, clock in. Remember always, anti means out, clock means in. And second point, oppose any change. And I believe it belongs to law of inertia. That is how we find the direction of induced current. Hope I could manage in such a way that you understood this. If yes, please do share. Thank you. See you with another video. Till then, take care. Bye bye.